So up next, we have Tim Wollery, Vice President of Sales with Advanced Chemical Technologies. He's going to present on his tech through the ITD program, preservation of concrete decks using Silane water repellents. So please welcome Tim.
Thanks for being here this late. And David, the drop test was way cool. I mean, that was great. So that was a lot of fun. So we're not going to talk a lot about my ITD project today because it's still in process. We're doing a bridge in Maine with a two-step system of Silanes and then epoxy sealers over it to extend to extend the life cycle of that bridge. But what we're going to talk about today is starting a preservation program. And I see Mel in the background. If anybody heard Mel's presentation, she is a champion for bridge preservation at the county level. So somebody worth talking to. So what we're going to talk about today is a little bit about concrete damage. You know a lot of this stuff, you've seen all this for the past few days. We're going to talk a little bit about what Silanes are. We're going to go through some of the testing, show you some application techniques, surface preparation, writing specifications, how to do that correctly so you get what you pay for, and then the cost of that Silane. So let's face it, water's the enemy. I mean, what we're trying to do is keep water out of concrete. So that's the biggest. You put de-icing salts on there, but if you don't it's the water that carries that down to the rebar, starting that corrosion. Water is also the enemy when it comes to freeze-thaw damage and also ASR and everything else we fight. So we see all this all the time, right? Spalling and scaling and cracking. These are the things that I have been noticing more and more around the country as I drive around, is that the car columns and piers are crumbling and the rebar is showing because they're underneath the bridge deck, and we think, well, they're fine, right? There's no water that gets there. But this is what we're seeing, and this could be easily fixed at the beginning if we were putting Silanes down. I mean, this is all water damage. ASR. I did a report in Arkansas a few months ago about ASR because they're starting to see a big problem with that. And as I studied that, it's been in the country really bad since the 30s. So it was in a few states. Then I found a report from the 1981 that said it was been in 9 states. I think it's way expanded beyond that. And I think some of the things that we see as freeze-thaw damage may really be ASR. So what is ASR? Alkali silica reaction. It's that reaction in the concrete. If you get reactive aggregates with the silica and then water, it forms this gel. And when that gel starts happening, you get this. And if you can see this in a lot of states, you drive at wing walls and things, you'll just see ooze out of that. That gel starts coming out of that concrete, starts expanding that concrete, and that's what you end up looking like. It can also make that concrete grow and ride above each other. So it's a real problem. So mitigation, non-reactive aggregates. Well, do you have time to research your aggregates when the concrete's being poured or when it's in the mix? Most of the time that is a big time study to get done and know whether you're buying non-reactive aggregates. Probably not going to happen. So then in your concrete mix design, do you put in cementous, the substitutes, fly ash and things like that, which then change the composition of the concrete, had less water, or do you just pour the concrete and put water repellents on after the fact? If you keep the water out, the ASR is not going to happen. So what are Silanes? Silanes penetrate into concrete. Someone asked me the other day, do they fill the cracks? Well, they don't fill cracks as a film former does, but what they do is they line the walls of those cracks. And so which makes that water that much harder to get down in that crack, and it also evaporates out of that concrete. So this is kind of what it is. If you look at these structures, that top left one is, that's concrete's been treated with a film form. And as you can see, it has formed this film all in that concrete. That looks great, but then what happens when that film former cracks? You get the chance for the water to get back through there. The right side is the untreated substrate. The bottom left one has a silane treatment to that. So what you can see is that it becomes part of the concrete. It's not a film that's in there, but it is an actual part of that concrete. So does it wear off? No, because it's part of that concrete. This is loose sand, and if you go by the booth in there, you'll see loose sand there. This water drop has been sitting on there all day long. So that silane just becomes part of that sand. This is a block that's been dipped in silane, and you can see that where the silane did not penetrate to, it's wet. But wherever that silane penetrated down in that concrete, it is dry. And that's what silanes do. They just keep that concrete dry. So you have a silane guy walk in your office selling you silane. There's basically about 6 silanes are out there on the market. They all perform the same. So if somebody walks in and says, oh, well, mine's better than the next guy's, well, why is it better? Well, the big difference in these silanes is the size of that molecule. And that size of the molecule determines the dry time. So typically it's these functions, so like isobutyl trimethoxy is a very fast drying silane, and if you go to isooctyl trimethoxy, it's a very slow drying silane. They both perform the same function. One dries in 15 minutes, one dries in 4 hours. So you have a choice. That's kind of the choice when it comes to silane. Do I want to be on the bridge for 4 hours watching paint dry, or do I want to be on the bridge for 30 minutes watching that stuff dry? So time is money, so getting on or off that bridge quickly, mobilization costs you money, traffic control costs you money, getting on and off a bridge deck is important. This kind of shows you that molecular size of that silane. And that silane is a super small molecule, and that's why it can penetrate down in that concrete. People talk about siloxanes all the time. Well, you can see the difference in the size of that molecule. Siloxanes will be on the surface more so than penetrating in the concrete like the silane does. Testing of silanes. Silanes have been in this country since 1977. Oklahoma started putting silanes on bridges in 1977, and they have yet to stop. They have been tested by most DOTs around the country for over 30 years. They just keep testing them over and over and over. Here's the universities that are continuing to do studies today. Every year, we send more silanes to more universities to do more studies. It's like, okay, when will we decide that they work? You know, but the problem is we can't see them. You spray them on concrete, they soak in, and you go, wow, that works great. But we can't see what's happening, so then we just keep testing. How can something we cannot see keep working? This was a Wiss-Cheney-Elsner's test from 1985. They did a 48-week salt ponding study and showed that the concrete dried out faster than without silanes on it, and there was no rebar corrosion. And that's kind of that same test that we duplicated. Those are rebars that concrete cores that we poured, and then put silane on some. It's amazing how hard it is to make rebar corrode when you're trying to get it to do it. It must be easy on bridge decks, but trying to make it do it in a laboratory is very difficult. When we did this test, we tested them for a year, and then we thought, man, this isn't going to work. We threw them out in the parking lot to see what would happen. Then the next year we go, oh, they've rusted like crazy. So it's interesting how they can make these tests work. So this is what you get with silane. You're going to protect that rebar, so not only stopping freeze-thaw damage, but you stop the rebar corrosion. Performance tests, there have been tons of ASTM tests. Your states are probably writing those, but this is just some of those tests that they run. Freeze-thaw tests, moisture absorption, vapor permeability. One of the things that we talk about, well, we need our concrete to dry out. One of the things about silane, if you keep 85% of the water out, that concrete can dry out that much faster. And that's what we want. We want the concrete to remain as dry as possible. This is a little Rylum tube test. Let's see if we can. So this is a Rylum tube test that they do in parking garages and on buildings a lot of times. We don't do them on bridge decks typically, but you'll see the one on, I guess it's your left, my right, is untreated. The block on the left has been treated, and you can see that it's not drinking any water, but the one on the right is sucking water down in there as an untreated block. That's what you're looking for. They do this a lot of parking garages for warranty type work, but it just kind of demonstrates what they do. This was a study done by Oklahoma State University where one of the biggest questions that come up, well, how long do silanes last? So Dr. Tyler Lay at Oklahoma State University, who has some great YouTube videos, his name is Tyler Lay, great YouTube videos on silanes and concrete water repellents. But they took 60 bridges, 360 cores they pulled, testing for silane. So how long does it last? According to Dr. Lay, they last 6 to 12 years. 100% of those bridges that were 6 to 12 years old still showed the presence of silane. 15-year bridges that were 15 years of age showed 66% of them still showed silane, and bridges that were 70 to 20, 21% of them still had silane. So how long do silanes last? Obviously, Dr. Lay thinks they last 12 years. We like to see them recoated more often than that, just because you get cracks in the concrete. other things are going on there. It's inexpensive to do. You might as well keep retreating those bridges. So let's talk about application. So surface preparation, some states sweep their bridges, some states power wash, a lot of states Oklahoma shot blast their bridges. They're probably the only state that I know that shot blast prior to putting silanes on. But what Oklahoma does is they build a new bridge, they let it sit for a year, and then they go and they shot blast it, apply silane, and if they have cracks, they may fix cracks and things like that. Sweeping is probably the majority of the places I go to. They blow them and sweep them off and start putting silane down. So this is a shot blast. You all know what a shot blaster looks like, but this is what Oklahoma does in shot blasting for a surface preparation. And you can see how well that really truly cleans that concrete, opens the pores of the concrete, makes that, it just helps it absorb that much better if the bridge deck is that clean. As far as application goes, so this is a spray bar. This is one of our favorite methods to have silanes applied. As you can see, that spray bar is very close to the ground. There's very little overspray this way, there's very little bounce back, there's very little waste. When you're buying silane, what you want to make sure it gets from that bucket on that concrete. And we think this is probably the best way to do this is with a spray bar. This happens to be on an Arkansas bridge, and you can kind of tell that is tinted blue. Some states we dye the silane so that the inspector can come by and say, okay, I've seen that bridge has been treated. So Oklahoma dyes theirs, Arkansas does, and now New York State's doing theirs that way. Spray bars are a nice, efficient way to do that. This is a truck-mounted unit that a lot of maintenance departments are doing. You can see the thing to look at on a truck, if you're going to do a truck-mounted unit, it needs to be low to the ground. This is a pretty well-designed truck by a contractor in Illinois. This is a truck that Indiana Maintenance DOT did, and as you can see, it's very high off the ground. And when you watch it go, when you watch this video, you can just see that you could see the overspray happening there. You can just see that if it's 4 feet off the ground, how much that material is getting there versus what you want to get there. So if you're going to design a truck, this is not the right way to do it. So, and they have since fixed these trucks, by the way, but when they first did them, this is how they did them. And you can see traffic is still going on while they're doing that. Obviously, handspraying is another way to do that. It's not the most efficient way to do it, but it's fast. And for doing barrier walls and things like that, if you can't turn the spray bar up, it's an efficient way to do that. So application techniques are pretty easy. So writing specifications. Biggest thing is to be consistent in writing your specification if you're going to write a specification. So don't count on what the manufacturer says on that label. I dislike it when I see use the manufacturer's recommended application rate, because they're going to write that application rate very wide range, 125 square feet to 400 square feet per gallon. They all do it. We all do it. It's a big wide range. It depends on the concrete, things like that. But when you're writing a specification for your bridges, it needs to be consistent. So most of our testing is done at about 11 grams a square foot of silane. So if you put a 20% silane down at 60 square feet per gallon, you're going to get 11 grams of silane per square foot. That is a pretty good magic number. 40% silanes at 125 square feet per gallon, and 100% silanes at 300 square feet per gallon. More is always better, as long as it soaks in. But this is kind of the minimum it should be if you're going to write a specification, because you want to get what you pay for. You paid for it, you want it on the bridge deck. You don't want to say, oh, well, just do it however you want to, and the guy walks out there and puts 40% silane down at 250 square feet per gallon. You get half the amount of silane that your bridge deck really needs. So when you're writing specification, put down there what you want on that bridge deck. Let's talk about the cost. You're going to see here that like a 20% silane, the cost per gallon is less, but when you get down to the cost per square feet, it actually goes up. And when you say, well, why is that? Well, every time we have to touch it in a manufacturing process, the cost goes up. We have to QC it again, we have to put solvents in it. They're just doing more things to that, which adds to that cost. So as you can see, a 20% silane goes down about 25 cents a square foot. A 40% silane at 125 square feet per gallon goes on at 20 bucks a gallon, 16 cents a square foot. And 100% silane, which a lot of states are starting to switch to, which why wouldn't you? When it gets down to 12 cents a square foot of application, If your maintenance people are doing it, they're out there on those bridges. 12 cents a square foot's a pretty inexpensive bridge preservation treatment to get started. I mean, it's like, why not? Let's look at a bridge. And I saw yesterday that on a presentation, the bridge cost was like $180 a foot. So this one was a typical bridge in Oklahoma out in the country. It's 150 by 38 feet at $140 a square feet. When it is $800,000. So we built an $800,000 bridge. It's a 5,700 square foot deck there, and it requires 45 gallons of silane. So $912 to start protecting your $800,000 investment or your asset. The analogy for me is if you had an $800,000 car and the oil change was $900, would you do it? Probably, because you want to keep that car going. So it's like, why aren't we doing this to every bridge deck in the country? Silanes have been tested since 1977. It's a proven preservation material. It's never too late to start. Even if you've got chlorides in your bridges, if you start keeping the water out, those chlorides are going to just kind of freeze right there. They can't keep driving down to that rebar if there's no water taking them there. Obviously that they're very cost effective. It's easy for local crews to do it. They're inexpensive. They have a really nice life cycle. I mean, if you're going to retreat every 6 or 7 years and you get in that cycle, it becomes very easy to do that. Wisconsin retreats their bridges about every 3 years. And they have some pretty nice bridges up there. Silanes, they stop freeze-thaw damage. They stop ASR, and they stop rebar corrosion. I mean, it is pretty simple what it's a very simple application with a very complex chemistry. Questions?
Curious, if a concrete deck has the saw cut skid resistant surface, it'll have more square foot per square foot, you know what I mean, of surface. Does that impact how much silane you'd put down on that versus a flat surface?
So the question is, if it has saw cuts, is it going to take a lot more silane, basically, right? You know, we do a lot of saw cuts, and they still put it down at 125 square feet per gallon. It may puddle in those, but it's still going to penetrate in there. The thing about silanes, you just don't want them to puddle. They have to soak in to work. So typically, you know, it's a vertical surface there, so that silane is going to be down that saw cut and just penetrate. So there's really not much difference in application rate on saw cuts. That's a great question. I appreciate it. Thanks.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.